Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Battery Boy 42. Thanks for the suggestion, Battery Boy. You asked, what is the difference between watts and volts? Ah, yes, the great confusion that has haunted humanity since the dawn of light bulbs. You look at your phone charger and it says 5 volts. Your hairdryer says 1,200 watts. Your friend who thinks they know science says, it's all electricity, bro. And you nod politely while secretly Googling it. Don't worry. By the end of this video, you'll finally know the difference, and you'll be able to correct your friends at parties, which is the true reward of knowledge, right here on Explaining Everything. All right, let's start with volts. Imagine electricity is water flowing through a hose. In that analogy, voltage is the pressure pushing the water through. It's the oomph, the push, the motivation your electrons need to move. So when we say something is 5 volts or 220 volts, we're basically describing how strongly the electric pressure is being applied. More volts equals a stronger push. That's why your phone charger is 5 volts. Gentle, calm, like a yoga instructor guiding electrons to your battery. Meanwhile, your wall socket might be 220 volts. A brute force gym bro of electricity that can power your air conditioner and fry your phone if you're not careful. Fun fact, volts are named after Alessandro Volta, an Italian scientist who built the first true battery. The man literally invented the concept of stacking metal coins to make electricity. Now let's talk about watts, the one everyone pretends to understand. Watts measure power, or how much work electricity is doing. Think of it like this. If volts are the push, watts are the result of that push. In our hose example, the watt would be how much water actually comes out. Pressure and flow combined. So even if you have a ton of voltage, if there's barely any current, the actual moving electrons, you won't get much wattage. Mathematically, it's simple. Watts equals volts multiplied by amps. Volts give the push, amps provide the flow, and watts tell you the total power party happening. Basically, watts tell you how hard electricity is working. It's the difference between a lazy jog and a full-on sprint. The higher the wattage, the more electrical energy is being converted into something: heat, light, motion, or in the case of your gaming PC, pure RGB glory. So next time you see a light bulb labeled 60 watts, that's not random. It means the bulb uses 60 watts of power, 60 units of electrical work per second. So, how do volts and watts actually differ? Well, voltage is potential, while wattage is performance. Volts tell you how much energy could be delivered. Watts tell you how much energy is being delivered. Think of volts as the size of a punch and watts as whether it actually knocks you out. You can have a high voltage system with little current, like a stun gun, which delivers thousands of volts but barely any watts. It shocks but doesn't fry you. Hopefully. On the flip side, you can have lower voltage but a ton of current, like a car battery. Only 12 volts, but it can deliver hundreds of amps. Enough watts to crank your engine, but thankfully not your brain. In short, volts equals push, amps equals flow, watts equals push times flow. So when you plug something in, volts are supplied by the outlet. Current depends on the device's needs, and watts are the total energy being used. That's why different countries have different voltages, like 110 volts in the US and 220 volts in most of the world. But your laptop charger doesn't explode, usually because it's smart enough to adjust the current it draws to keep the wattage steady. Here's where it gets interesting. Volts and watts aren't rivals. They're partners. Think of them as a tag team. Volts provide the push. Watts show the power. Without volts, nothing moves. Without watts, nothing gets done. That's why your laptop charger can be just 20 volts, yet still pack 60 watts of power. It's not about how hard it pushes, but how efficiently it works with current. The same goes for light bulbs. Two can both use 60 watts, but an LED turns that into bright light, while an old bulb turns most of it into heat. So, when volts and watts work together efficiently, your gadgets run cooler, faster, and smarter. Proof that teamwork really does make the circuit work. In the end, volts are all about potential. They're the push, the pressure, the reason electricity even starts moving in the first place. Watts, on the other hand, are the power. They measure how much work that movement actually accomplishes. Volts create the opportunity, but watts deliver the results. Think of it like this. Volts are the motivation. Watts are the muscle. One gets the electrons ready to move. The other shows how much they can actually do. So the next time you look at a label that says 220 volts or 60 watts, you won't just see random numbers. You'll see a perfect little story of energy in action. Electricity might still be invisible, but now you can finally see how it all connects. If you enjoyed this video, or if you now know what type of charger your phone needs right now, leave a like and don't forget to subscribe. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.